Hello, my name is Islam Deep and I am a PhD student at the University of Oulu. Today I'm going to present our recent work, Smart Campus, based on LoRaWAN, the dataset, and the people counter application. This work is done as part of the Fireman project. In the outline, I will first present the motivation and I will briefly describe the network deployment of the devices, the dataset description. Then I'm going to present the system model and the performance analysis and the proposed people counter model. And finally, I will present the simulation setup and results. And then I will conclude the presentation. LoRa is a low power, low range, low data rate technology, and it operates in the ISM band and it uses the Shrub spread spectrum as its main modulation scheme. LoRaWAN is a technology that uses the LoRa as its physical layer, and it is very useful in serving massive number of machine-type communication devices, and it has huge scalability. It is widely used in smart campus as it can serve massive number of devices. Our dataset is called the Smart Campus Dataset, and it is an open research dataset that focuses on industry-academia collaboration network building, and it has hundreds of devices deployed in the main campus of the University of Oulu. It is now very useful to know and ensure the number of people inside a closed room. As we know, during the pandemic era, we need to ensure that uh, each closed room has a certain number of people, and also the smart buildings and smart cities now has this rule to ensure a smart air ventilation systems which count the number of people in the room in order to ensure clean air in each room. In our dataset, we have sensors that measure physical parameters such as the CO2, the temperature, and so on. And we can use these parameters to measure or to count the number of people inside this room. In addition, we will present a solution to handle any failure transmissions or any missing data in this dataset and use the output of this failure handling in order to count the number of people. As you can see in this map, this is the network deployment of the devices in the campus of the University of Oulu, and this is the distribution of the devices. This is a snapshot of dataset. We have two set of datasets. The first dataset is the LoRa parameters dataset. It describes some LoRa parameters such as the SNR and the transmission power, the sequence number, the frame counter, and the port used, the channel used. And the second dataset is the actual physical parameters sensed by the sensors such as the temperature, CO2, and the sound. There are 462 devices that are classified into three types: CO2 devices, sound devices, and moisture devices. The CO2 devices mainly measure CO2 motion light. Sound devices mainly measure sound average, sound peak, motion light. Moisture devices are in the soil that measures the moisture and the pressure. All the devices measure temperature, humidity, and battery level. We collect both datasets in the period frame from February 2020 to June 2021, and you have around 7 million data rows in each dataset. Here, the system model. So the LoRa devices sense the physical parameters. These sensors transmit to a gateway these measurements. Then the gateway relay the data to the server, and this happens every 15 minutes for each sensor. We have here an example of CO2 device, an example of a sound device, and an example of a moisture device measurements for its own sensed physical parameters. We have the range of readings for this sensor in the period of collecting the datasets. Here we have an advanced analysis where we calculate the max, the min, and the mean for all the parameters for all the devices. In the first figure, we show the max measurements for all the parameters. In the second figure, we show the min analysis, and finally, we show the mean of the readings of each physical parameter for all the devices. So we formulate the people counter model as two phases. The first phase is called data imputation and pre-processing. The second one is called data analysis. In the first one, we identify the failures or the missing data, and we handle them by dropping them, imputing, or predict the missing value. In the second phase, data analysis, we first predict the future data, and then we formulate the people counter. For the failures identification, we rely on the frame counter parameter in the LoRaWAN dataset. When we have a missing counter, it will not count the frame as successfully transmit, and we will identify a failure in this time. And we can verify this using the 15 minutes gap between each successive transmission for each device. We can handle the failures by either drop the missing value or replace the missing value with 0, or use interpolation, linear interpolation or polynomial interpolation. Finally, we can predict the failure, the missing data using the KNN or neural network. In the second one, we use LSTM to predict the future data, and this is as a verification of the handling the missing data is working fine. And finally, we use the people counter and the neural network to formulate the people counter model. As I mentioned, we collect this dataset in the period February 2020 to June 2021, and we count the number of people inside the room in order to collect the training dataset. We, of course, did some pre-processing steps, like removing the outliers, normalization, and after we formulate or identify the failures or the missing transmission in the dataset, we try a bunch of techniques to handle the missing values as linear interpolation, polynomial interpolation for the second degree or third degree, dropping the value replaced with 0, or using KNN with k equal 3 and k equal 13. And we calculate the root mean square error between the so we collect a clean dataset with no missing values, and we try all of these techniques, and then we compare the predicted one to the actual values, and we calculate the root mean square errors. And as we can see, always the prediction using KNN works fine, and also the linear interpolation works okay when handling the missing values. Then we use the handled missing values in order to predict the future CO2 values. And as you can see in the first figure, we have the LSTM training loss to predict the future CO2 values, and in figure C we have the predicted ones. And as you can see, the KNN is slightly better than the linear interpolation. We have this problem in the collecting the number of people inside a room. So we have imbalanced support set between the number of people inside a room. So we use oversampling in order to balance the data a little bit. we formulate a neural network in order to predict the number of people using the physical parameters inside this room, and the CO2, the sound, the light, and the motion, and other physical parameters. And as you can see in the first figure, the training accuracy while adjusting or increasing the epoch numbers. And in the second figure, we have the training loss. Here is the results. We have the confusion metrics and the classification report. And as we can see, we achieve an accuracy of 95% of predicting the number of people. So, in conclusion, we have KNN and vendor interpolation outperforms other schemes in handling missing data. LSTM is very efficient in predicting the future measurements. We use the deep neural network to formulate the number of people using the sensor readings. And finally, if you are interested in this work and in the notebooks used to produce this kind of work, I encourage you to go to our GitHub link in the description. And also, if you are interested in using this open source dataset, I encourage you to access this dataset from the link also in the description. And thank you for watching. Any question? Don't hesitate to contact me using my email. Thank you.